Hi everyone, welcome back to Stoichiometry Chem Corner. In today's video, we are continuing the AP Chemistry Basic Series. As you know, it's not just for AP students. Honors Chemistry or other students struggling with this kind of topic, I'm damn sure it will be super helpful. So the whole playlist I'm pinning here so you can check it out. Let's get started. So in today's video, let's explore the concept of limiting reagent. So see, limiting reagent is the continuation of stoichiometry. So if you didn't see the stoichiometry, you didn't get this video. Okay, so first make sure you are already study the stoichiometry. I'm already given the video, so you can check that video. Okay, so what about limiting reagent? So stoichiometry, what we studied, H2, some chemical reaction where we take some example like H2 is reacting with the oxygen and forming water, and we know that some stoichiometric coefficients are involved, isn't it? The balanced chemical equation says that this is 2 and this is 1 and this is 2. Okay, so what is this coefficient meant? The coefficient is meaning their mole ratio, isn't it? So the ratio means like 2 hydrogen require 1 mole of oxygen and they will form 2 moles of water. Okay, what we studied? If 2 moles of hydrogen is there, it require, we don't know how much it is there, but it require 1 mole of oxygen, and so that they will form a 2 moles of water. That is the meaning. Okay, that is this ratio mean. Now just think about the situation, like 2 moles of hydrogen is there, but there is only 0.5 moles of oxygen is only there. Okay, see the situation, 2 moles of hydrogen is there, it require 1 mole, but we didn't have that much. We didn't have that much, like 1 mole hydrogen or oxygen is not there, we have only 0.5 moles of oxygen. At that time, do you expecting there is 2 moles of water? It's not, isn't it? Because hydrogen and oxygen, both of them togetherly react and forming water. If 0.5 moles of oxygen is there, see the oxygen ratio, 1:2. See the oxygen ratio, 1 oxygen forming 2 water. So 0.5 moles of oxygen will form only how much? Yes, 1 mole of water. So after forming 1 mole of water, the oxygen is completely end. It's completed. There is no further oxygen in order to continue the reaction, isn't it? So the reaction will stop at that time. When 1 mole of water is formed, at that time the reaction is done. So that is why you can say oxygen is the limiting reagent in this case. Okay, oxygen limits the amount of water formed. Oxygen limits at the point of 1 mole of water, isn't it? So that's why that's the concept of limiting reagent. So do not just merely look 2 moles of hydrogen, 0.5 moles of oxygen. Okay, oxygen is low in number, so oxygen is the limiting reagent. No. Okay, do not consider the limiting reagent concept like that. That is completely wrong. What is the point of, what is the actual thing limiting reagent? Limiting reagent is the one which is lower than the required amount. Okay, so even this is 2 moles of hydrogen. So we are just thinking about the ratio. 2 moles of hydrogen require 1 mole of oxygen, but we didn't have that much. So 0.5 is less than 1. Okay, that is the reason. 1 is what? The required amount. So if we have less than the required amount, that reagent is what you called limiting reagent. That's why oxygen is a limiting reagent. Okay, and the other one you can say excess reagent. Why it's excess? Because see the reaction, if 0.5 moles of oxygen is there, now what has happened? 0.5 moles of oxygen is there and they will form 1 mole of water. Okay, but 0.5 oxygen require how many moles of hydrogen? Again see the ratio, 1:2. So 0.5 moles of oxygen require only 1 mole of hydrogen. But what we have actually, 2 mole of hydrogen is there. Which means out of 2 mole, only 1 mole is reacted. So this is the reacted amount. Okay. So what is the leftover? Yes, 1 mole of hydrogen is left over. Why? Because 2 minus 1. Okay. 1 mole of oxygen is excess in that situation. Clear? So this is happened in this scenario. Once again, this is some complicated concept, so just think about once again. Again, I am telling, first consider the reaction 2H2 plus O2 gives 2H2O. Okay. So, what is our situation? There is 2 moles of hydrogen and 0.5 moles of oxygen is there. So, what is the question? What is the moles of water formed? Correct. And the next one, who is the limiting reagent? And the third one, what is the amount of excess reagent? You can get it from the reaction. So first of all, think about the reagent mole ratio. Compare the reagent ratio. You can take any of the reagent. So if you think about starting with the oxygen, think about it. See 0.5 oxygen require 0.5 oxygen require, yes, 1 mole of hydrogen, but there is 2 moles of hydrogen. So more than the required amount is there. Correct? More than the required is there. So hydrogen is the excess reagent because actually there is 2 mole. Okay? So this is less than the 2 mole. So that's why hydrogen is the excess reagent. So you can consider oxygen as the limiting reagent. So when you get the limiting reagent, then everything is based on limiting reagent. Like everything is determined by limiting reagent. If you want moles of water, you have to start with the limiting reagent. If you want excess amount, you have to start with the limiting reagent. Limiting reagent decide everything. Okay? How? 0.5 moles. So now you do not take the ratio of excess reagent. Did you understand? 2 moles of hydrogen get 2 moles of formed 2 moles of water. Okay? But that ratio you didn't take. Only the ratios are now it's based on limiting reagent. So 0.5 moles of oxygen will give 1 mole of water. That's why you can write here 1 moles of water. Similarly, 0.5 moles of oxygen can require 1 mole of hydrogen. So there is an excess. Initially 2 moles are there. Now it's 1 mole is consumed. So 2 minus 1, 1 mole of hydrogen is excessed. So these are the idea. Okay. So now let's think about in grams. For example, in the same thing, like again I'm just writing 2H2 plus 1O2 gives 2H2O. So now you think about if it were 10 grams of hydrogen and 5 grams of, or 50 grams of oxygen, what about the thing? If it is in gram, how do you do this one? Okay, if it's in gram, how do you do this one? Here also, you have to consider, as we studied in stoichiometry, 10 gram hydrogen, you have to first convert it to the moles of hydrogen so that you can use the molar mass. So, what's the molar mass? 2.02, I think, grams of hydrogen is equal to 1 mole of hydrogen. So, just simply I am just taking 2 so that it is 5 mole of hydrogen. So, 5 mole of hydrogen is there. What about the 50 grams of oxygen? 50 grams of oxygen, how many moles are there? 32 grams of oxygen is 1 mole of oxygen. So that will give an answer like 1.6 moles. 1.6 moles of oxygen. Now you just compare. 5 mole hydrogen actually required 2.5 mole. Okay, but what happened? Here it's less than 2.5, less than the required. So that you can say oxygen is again the limiting reagent here. Okay, so see the thing, as I told you, the someone with a lower amount is not the limiting reagent. See the initial value, this is 10 gram, this is 50 gram. See 50 gram is higher, but oxygen is the limiting reagent. Why? Because of this reason. Okay, so that's the point. Oxygen is the limiting reagent. In that way, you just convert to the moles and convert to the compare the thing. Okay, then what about the amount of water formed? Now it's everything is depend upon the oxygen because oxygen is the limiting reagent. If 1.6 moles of oxygen is there, you can think about the like times 2 because the ratio of water is times 2. So 3.2 moles of water will be there. Okay, how many like water is formed? And what about the excess reagent? Yes, 1.6 moles is again consumed. 3.2 moles 2 mole is consumed. 2 moles of hydrogen is consumed, so that the leftover hydrogen is what? Yes, see the initial amount. Initially there are 5 moles of hydrogen is there. Out of the 5 mole, 3.2 is consumed now, so that the remaining will be the excess reagent. Okay, so 5 minus 3.2 will be the excess what? Excess hydrogen. So excess reagent, leftover excess reagent is the main question. So every students are doing like just they will subtract some random numbers, like see if this is the thing 2.5 minus 1.6 or 5 minus 1.6, like that they just subtract some random number. It's not like that. First you have to calculate how much it is consumed. That consumption cost, that's not be the question part. Question is just excess reagent is what. But for getting the excess reagent, first you have to calculate how much it is consumed. Then only you can subtract. Okay, initial minus the consumed amount. That is the thing. Okay, this many moles of hydrogen is left over the reaction. Okay, left over. That's it. So now let's see, I will show some particular diagram questions. So here they were given a diagram and see the reaction 2A plus B is equal to C. And from this diagram, you have to say which one is limiting reagent. Okay, and also you need to draw the molecular model representation of amount of reactant and products left over the reaction. Okay, so these are the two things. First thing, you have to calculate the product, like the limiting reagent is what. Then you have to show the particular diagram, the molecular model diagram. Okay, so see the equation 2A plus B is equal to, it gives C. So when 2 moles are there, when you're looking the just number, the green balls are A, the red color balls are B. So see the number 1, 2, 3, 4, 5. There are 5 B's are there, and the A's are 1, 2, 3, 4, 5, 6, 7, 8. 8 A's are there. So can we say B is the limiting reagent? Is it? Yes. No. Okay. So we can't say that is not the what criteria. So criteria is what? Which one is less than the required amount. So let's see. Here also you can tell 8 require. See the ratio. 8 require. 2A require 1. So 8 balls are there. 8 represent like 8 A's are there. So it require only 4. 8 require 4 only. See the ratio 2 require 1. So 8 require 4 B balls. But see, it's greater than the required amount. So B is the excess reagent. B is the excess reagent. Okay, so that's the meaning. Or you can simply draw the diagram, like see 2A and 1B is forming 1C. So this is the molecular diagram. Okay, the second question is about draw the molecular diagram. So 2 B's and 1 A, 2 green balls and 1 A, 2 green ball and 1 red ball, you can consider like 1 C. Okay, then see the next one, again 2, this one, and again see this green, this you can draw here. There is 2 green ball and 1 B. So see, after the reaction we got 1, 2, 3, 4. 4 C's are there, and see the excess reagent. B is excess. After the reaction, B is there. So B is the excess reagent. 1 B is excess in there. Okay. So this is what they meant. Okay. Similarly, another diagram question is this one. Here also 2S and 3O2 gives 2SO3, and see the representation. S means this rectangle and O2 means this diagram, like this diatomic, that thing. Okay, same thing. You have to draw the particular diagram. ABCD option, MCQ options are there, so you can draw it. Okay, same way. 2S and 3, 2. So see the 2 diagram you can take 2 rectangle you can take, and 3O2. So that you have to draw a 3O2 here. Okay, and then again 2 thing and see this one. So there are only 2 products, and like 2SO3, each one is 2SO3, so 4 maybe you can find. And then what is the excess reagent? The rectangle box. Sulfur is the excess reagent. So any diagram like that? Yes. D is the correct diagram. Okay, 2SO2, that's why there is only one thing. Okay, so here 4 will be there. That's natural. Clear? Okay. So let's see the next question. Here they were given a propane is a common and natural gas. Okay. So and so it's a combustion reaction. Basically, propane combustion reaction, like it's reacting with oxygen and giving CO2 and H2O. So first step, you need to balance the reaction. Okay. So here 3 carbons are there. Here only 1 carbon, so 3 here. And here 8 hydrogen and 4 hydrogen you can put here. So that will make a total of 10 oxygen, so 5 O2. Okay, so in this way you can easily balance this one. If you didn't get the balancing, I'm given another video, like a separate video. I think I already given, or you can check it, that video. Okay, right. So see the next one, the question is, first one is balancing, and second one, how many grams of carbon dioxide can be produced by burning 3.65 moles of propane and 12 moles of oxygen. So the limiting reagent question, right? Because both the reagent, if both the reagents are given, so you think about the limiting reagent. If only one reagents are there, no issue. There is no question about the limiting reagent. Okay. So here 3.6 moles of propane is there and 12 moles of oxygen is there. So first step, we need to find the limiting reagent. Okay. So yeah, see the ratio. 1:5. Propane will give 1, or you can do the dimension analysis. So 3.65 moles of propane. See what is the ratio? Moles of propane is 1 and the oxygen ratio is 5 mole of oxygen. So you have to multiply with the 5. Okay. So how much is required? Yes, some 18.25 moles of oxygen is required, but do we have that much? We have only 12 moles of oxygen. So what happened? Oxygen is the limiting reagent. 12 is the less than 18.25. So oxygen is the limiting reagent. Okay. Then only, if you get the limiting reagent, then only you can talk about the grams of carbon dioxide. Okay. So for getting the how many grams of carbon dioxide, you have to start with the limiting reagent. Just now we got the limiting reagent is oxygen. So 12 moles of oxygen are there. So you have to start with the 12 moles of oxygen. Then mole to the mole conversion, like carbon dioxide. So you need to cancel the moles of oxygen and have to introduce the moles of CO2. So see the ratio, 3:5. Then again you need to convert to the gram. So 1 mole of CO2 is nothing but 44.01 grams of CO2. In that way, you can show the dimensional analysis and get the value. Okay. So the answer is 316.8 grams of carbon dioxide is formed. Okay. So for getting that one, first have to calculate the limiting reagent. Okay. Then what about the next question? How many moles of excess reagent left after the reaction? As I told you, even they were asking with the excess reagent, first you have to calculate the reacted reagent. Okay, how much it is consumed. What about the reacted excess reagent? Here it is C3H8. Okay, so again start with the limiting reagent. 12 mole of oxygen is there and 12 moles of oxygen, and see the ratio this time, oxygen and propane ratio, 5 moles of oxygen at the bottom and at the top 1 mole of, because the ratio, see, it's just 1 mole of C3H8 and moles are asking, so you can stop the dimensional analysis here. Okay, so here how many moles are there? Yes, I think 2.4 mole. 2.4 moles of C3H8 it is consumed. Okay, then then you can easily calculate the excess reagent. So initially, how many moles of C3H8 are there? See the question. There were 3.65 moles of propanes are there. Okay, so 3.65 was there. Out of 3.65, now it's 2.4 is consumed. So the remaining is 1.25 moles. Okay, so 1.25 moles of what? Propane is the excess reagent. Okay, C3H8. That's it. Then see the next one. What is the percentage yield if 290 gram of CO2 is obtained? So see the question. What is the percentage yield? So what we are talking about, what we done already, like how many grams of CO2 will be formed in this reaction? See the question number B, we already found 316.8 grams of CO2 will be formed. Okay, that is the theoretical yield. What theory says we will get 316.8 grams of CO2. But when you are doing in lab, you didn't get the exact amount maybe. Due to the various lab condition, what happened? You didn't get the 100% yield. Okay, you may get something lower than the theoretical amount. Okay, so here what the question says, they were telling if 290. So we are expecting the theoretic we are expected 316.8. Okay, 316.8 we are expected, but what we got only 290. So what is the percentage yield? So percentage is nothing but actual yield. This is the actual yield. Okay, actual yield divided by the theoretical yield. Okay, times 100 is actually the percentage yield. Okay, that's it. So what is that one? I think it is 91.5%. Clear? That's all. So the percentage yield is nothing but actual yield over the theoretical yield times 100. Okay. Then the last question. If 90% was the yield in B, then what should be the mass of product? Okay. So just like another way of question. The percentage yield, same from the percentage yield. We are expecting, if you are expecting 100%, you will get 13.8. So if it is only 90% product we got, then 90 of this one. Okay, is that the actual amount? Yes, that will be the actual amount. I think it is 285.12 grams of CO2. Okay, so that's the thing. That's the idea. That's the whole stoichiometry. So through this, see the 6 problems are there. Through the 6 problem, what I thought I can explain the whole stoichiometry with the limiting reagent. Okay, when you like, are you okay with this 6 kind of question? Then the whole stoichiometry is over. The whole stoichiometry with the limiting reagent lies in this 6 question. So master this thing, then you get the full score on based on the stoichiometry. Okay, right. That's all.